We're going to practice integration by parts today before we jump next class into other techniques of integration. Remember, U substitution undid the chain rule. Integration by parts undoes the product rule, although knowing that doesn't necessarily help us apply it, but still good to remember. U substitution works in examples where we have a function and its derivative lives somewhere in the expression. Integration by parts works when we have two functions multiplied by each other that are not really connected via derivatives at all. So let's compare two examples here. So x e to the x squared is one that we did last class, and then x e to the x is one we're going to do today. So last class we saw that if I pick x squared to be my u, its derivative with a constant is x. And so U substitution works nicely on this first one. Whereas if I tried to pick x to be my u in this other one, its derivative is 1. That doesn't work great. It's not going to cancel this x out with U substitution. So we really think that x and e to the x are two functions multiplied by each other that are not related via derivatives. So this is going to oftentimes work if we have like a polynomial and a trig function multiplied by each other, a trig and an exponential and a polynomial, two functions that are very different multiplied together. So let's remember what the integration by parts formula says. So integration by parts, we start out by picking a u and a dv. These are two pieces that when they're multiplied by each other, give us the expression inside the integral. And so integration by parts says that that integral is going to be uv minus the integral of v du. Again, I remember this as UV, like UV rays from the sun, minus voodoo, minus the integral of voodoo. So you can figure out how you want to memorize that. So in this case, we have to pick our u and our dv. Probably one's going to be x and the other one will be e to the x, and we have to figure out which one's which. This is where we have lip-t. Let me write this over here. So lip-t helps us pick our u. This is for picking u. And so we pick the first thing that appears on this list in our integral. So L is logs, I is inverse trig, P is a polynomial, T is just a general trig, and X is exponential. You can spell exponential correctly. Sorry, guys. So we look down this list. We don't have a log in this expression. We don't have an inverse trig function, but we do have a polynomial. X is a polynomial. So we pick X to be our u because it was the first thing that appeared on this list. And so that leaves our dv to be e to the x dx. Now we have to find du. The derivative of x is just 1. So we write 1 dx. For v, we integrate dv. Integral of e to the x is e to the x. So now we just have to put everything back together. So we're going to have uv minus the integral of v du. U is x, v is e to the x. V is e to the x, du is just dx. And then we still have to compute this integral. Sometimes that's harder than others. Here, this is pretty easy. The integral of e to the x is just e to the x, and then don't forget our plus c. Remember, sometimes we have to do integration by parts twice, which means that like this piece might need another integration by parts. This problem worked out nicely, but we'll maybe see a few more complicated ones in class.